Hi everyone. In this video, we'll give a quick summary of our ICCV 2023 paper on Agile modeling, from concept to classifier in minutes. In this work, we consider classification tasks from computer vision and machine learning. Up until today, the majority of label data that we use to train such models is rated by crowd workers. And while crowdsourcing has served the vision community well for a long time, for many objective tasks such as identifying ImageNet concepts like zebra or tiger, nowadays there is an increasing demand for more subjective concepts for which it is difficult for crowdsourcing to perform well. For example, a sushi chef might want a classifier to source gourmet tuna for inspiration. However, in their mind, a positive example would be an image that not only shows tuna, but is also an elegant gourmet plate where tuna is the star of the dish. The subtleties of what is elegant and gourmet may be difficult to pass over to crowd raters. Or, alternatively, it is possible that crowd workers don't have the expertise to always distinguish tuna from every other type of fish. So there are cases where we want to give the user or domain expert the power to create their own models. In this paper, we define the problem of agile modeling, which introduces the process of turning any visual concept into a computer vision model through real-time user-in-the-loop interaction. This empowers users to drive the modeling process and create their own classifiers. In our paper, we identify the components needed in our agile modeling system, and we propose a prototype with a particular instantiation of these. We assume the most extreme case, where we start with no label data at all, and we ask the user to initiate the process by providing a set of text phrases that describe their concept. In our gourmet tuna example, the user may provide some positive queries like tuna sushi or seared tuna, as well as some negative queries for what the concept is not, but might be confused with, such as canned tuna. Next, our system will automatically expand these text queries and retrieve relevant images. We do a careful selection of a small subset of these images, on the order of 100 images, and we ask the user themselves to rate these as positive or negative through an intuitive rating interface. Now we can train our first classification model, and this model can be further improved with one or more rounds of active learning where, again, the user is the rater. For a concrete implementation of these components, please see our paper. However, there are two important constraints to keep in mind. First, the user requires no machine learning or engineering expertise. Here, they only describe their concept in text and rate some images. Secondly, everything needs to be implemented in a fast and efficient way, since we don't want our user to be idle while the system is running any components of this framework. We ran experiments with real users where 14 volunteers were each assigned a different concept to model, and we chose concepts based on suggestions from real-world practitioners. Each participant used our agile modeling prototype, starting with no labels and an unlabeled pool of 100 million images drawn from the Lion 400 million dataset. We evaluated the model performance after 6 rounds of image labeling and compared it with that of pre-trained zero-shot models using 2 types of image text embeddings, clip and align. We observed that the performance of the Agile classifier trained from scratch always beats that of the zero-shot classifier. However, the gains and final performance of the classifier vary based on the concept difficulty and the type of embeddings that we used. Averaging over all these concepts, we can now observe the trade-off between the time the user spends with our system and the model performance. In just 5 minutes of work, the resulting model outperforms zero-shot by 3% and continues to improve with each active learning round. After 24 minutes, we get a 16% increase in performance. We also compared the performance of models trained with labels from users versus crowd raters and found that, especially on hard concepts, that is, those concepts where the zero-shot model doesn't perform well, models trained with user labels, marked in red on the plots, outperformed the models trained with crowdsourced labels, marked in blue, even when we obtained 5 times more ratings from the crowd. We also performed experiments at scale on ImageNet concepts. Please feel free to pause or check out our paper for details. Finally, to summarize our contributions, we formulate the Agile modeling problem, which puts the user at the center of the image classification process. We demonstrate that a real-time prototype can be built by leveraging state-of-the-art image text co-embeddings. Our prototype trains models from scratch that beat pre-trained zero-shot models in 5 minutes. We compare models trained with labels from real users versus crowd raters and find that the value of a user increases when the concept is nuanced or difficult. Finally, we verify the results of the user study at scale with a simulated experiment on 100 concepts from ImageNet. You can find more information in our paper and our GitHub repository, and please feel free to contact us with questions and suggestions. Thank you for your attention.